Lesson 16, trigonometric equations. Now, this one we're going to use a lot of information all together, okay? Now, we're going to start with problem 2a. Make sure you notice the note here. There's a lot of different methods that we can utilize, okay? But we're going to go ahead and stick to the things that we're comfortable with, the things that we know how to work with. And if you did not do all the practice, all the homework of all the previous sections, this section will be a nightmare. Okay. Now, let's go ahead and take a look at this thing. I've got 2 sine squared x, cosine of x minus cosine of x. Okay. And I'm thinking to myself, I'm asked to solve this equation. Okay. There's got to be a number of methods that I can consider. Well, the first method, number one method that I always want to try, okay? And because it always worked in the past, let's try it now. I'm going to try factoring, okay? Is there a way to factor this particular problem? Well, it's equal to 0, so what can I factor? Well, I know I have this thing is 2 times sine of x times cosine of x minus a cosine of x. You'll notice that in both of the terms, this being one term, this being another term, okay, there's a cosine of x in there. Why don't I just factor that out, okay? So I'm going to go ahead and factor out cosine of x. That's going to give me 2 sine squared x minus what? Well, when I factor out the cosine, it's going to be 1, okay? And that's supposed to be equal to 0. So now I have this situation, which is actually just perfect, because that gives me the cosine of x is equal to 0, okay? And the question is when does that happen? When is the cosine of x equal to 0? For what values of cosine, okay, what values of angle measures does cosine equal 0? Well, if I look at the unit circle, okay, cosine of x is the x value, when does it 0? Here and here. What values are those? Well, pi over 2, okay, and 3 pi over 2. Now I'm going to hold those for solutions, okay? That's what I'm getting from that. But I also have another factor, okay? I have this factoring equal to 0, but I also have the case that this factor could be equal to 0. So let me go ahead and jot that down. I have 2 sine squared x minus 1 is equal to 0. And let me solve for just the trig function. I'm going to add 1 to both sides, get 1 is equal to 2 sine squared x. Okay, I'm going to divide by 2 and get sine squared x is equal to 1/2. And then I'll square root both sides, yes? So I have the sine of x is equal to the square root of 1 over 2. I pause there for a minute because you should be asking, or at least yelling at me through the screen, that you should always have that plus or minus there, okay? Likewise, I can tear this thing apart to make it plus or minus the square root of 1 divided by the square root of 2, which is really just plus or minus 1 over radical 2, which is the same thing as plus or minus radical 2 over 2. Again, if you're not following all that, I strongly suggest you play the mathematics there, okay, just the arithmetic. So when does sine of x equal plus or minus radical 2 over 2? Now, there might actually be a lot of answers for this. So over here, okay, I'm going to go ahead and jot down when does that occur. That's all of them, okay? I have pi over 4, 1 pi over 4, 2 pi over 3 pi over 4, 4, 5 pi over 4, 6, 7 pi over 4, okay? All of those values is where the sine of x could be radical 2 over 2. So, that means that my x value could be pi over 4, 3 pi over 4, 5 pi over 4, I wrote 5 here, and then 7 pi over 4. Okay, these are all possible answers for this exact same problem. Now the questions are they valid? Okay, all 6 of these values for x, are they all valid? Will they all check out? Okay, now what I'm going to look at is I'm going to look at the actual problem again, and it says solve this where I have 0 is less than x is less than 2 pi. Okay, I will not fully anticipate that you check all these values. Now you should, okay, you really should. But what I would suggest is type into the calculator, take a look at the graph, okay? Look to see that there are actually 1, 2, 3, 4, 5, 6 solutions on that graph. Does it cross 6 locations between the values of 0 and 2 pi? If they don't, then I have to go through and check them. I have to plug them in to the original equation and check to make sure it equals 0, okay? Otherwise, again, and when we look at this graph, all of these are possible options. Notice all of these are also between 0 and 2 pi. So for this particular problem, we have found all the values. And all these values will check out. Again, we should technically be checking them. I'll check 1 to verify. 2 sine squared of pi over 2. Cosine of pi over 2 minus cosine of pi over 2 is equal to, well, cosine of pi over 2 is 0. This whole side is 0, minus this being 0, so I get 0. Check. Okay, again, you should technically go through and check them all. If you look at your calculator and visually see that there are those 6 solutions, all between 0 and 2 pi, I will accept that as being okay to check, okay? Let me know that you're checking them. If some of them don't seem like they might check out, make sure you put an X through it, okay? And that can occur. Okay, let's look at 2b. Okay, now 2b, there's a number of different ways to solve sine of x plus cosine of x is equal to 1. Okay, one of the ways is to take this thing and change it to the function it really is. Now we did that back, I believe, in lesson 14, where we have to change this thing to be in the form of k sine of x plus alpha. That is one way we can do this, okay, changing it to be that. It's not necessarily the funnest thing to do. Okay, there's actually a lot of work involving in that. So what we might do instead is say, let's get one of the trig functions by themselves. Okay, so again, I'm going to look back at this. This is a way you could do it. This is not the way the textbook does it. This is the way that I would think to do it. Okay, so with this right here, what I'm going to do is this. I'm going to go ahead and say, well, I have sine of x plus the cosine of x is supposed to be 1. So therefore, my cosine of x is equal to 1 minus sine of x. Okay. Now, what could I do with this? Well, there's a number of different things I could do. Okay. But the one that I would strongly recommend that we attempt first is squaring both sides. And now you're looking at me, why would I want to square both sides of this thing? Well, if I square this side, it's just cosine squared. That's fine. If I square this side, what am I going to have? Well, you'll notice this is going to be 1 minus 2 sine x plus sine squared x. Okay? Now, with that done, I don't really care for the fact that I have 2 different trig functions. That's the real problem. It's not that the fact that this is sine of x and this is cosine of x and they're added together and I have two trig functions added together. It's that they're 2 different trig functions added together. Okay, so why don't I just take this over here and change it to be sine now? Okay, I can do that. I know the identity for that, you know, the Pythagorean identity, cosine squared x plus sine squared x is equal to 1. Okay, so I'm going to go ahead and change that over. This is 1 minus sine squared x is equal to 1 minus 2 sine x plus sine squared x. And now I can go ahead and get everything to one side. Okay, the way I'm going to do that is I'm going to add sine squared x to this side and add sine squared x to this side, and I'm going to subtract 1 from both sides. Okay, that's going to give me 0 is equal to, the ones are going to cancel out. I'll be left with 2 sine squared x minus 2 sine x by factoring this problem. Okay, again, back to factoring. If we can see it, we might as well do it. I'm going to factor out a 2 and a sine x, and that's going to give me sine x minus 1. This is all supposed to be equal to 0. Okay, so now I'm going to move up here, okay, and I'm going to go ahead and say, hey, I have 2 sine of x is equal to 0. Again, 2 sine of x equals to 0. And then I'm going to have sine x minus 1. Sine x minus 1 equals to 0. This one here gives me sine of x is equal to 0. Again, for what values of x does this work? Well, that's going to be x is equal to, I believe it's, for sine, it's the values of 0 and pi. Yes? Okay. And I'm going to look at this. Where is sine of x equal to 1? Okay, where does sine of x equal to 1? And that set of values is going to be just x equals pi over 2. Okay, so now we have 3 different solutions here, and we're going to go ahead and say these should all work, right? I mean, logically, they should. We got all these values. They should all check out. You can take a look at the graph. Now, the graph actually does show only two real solutions here. Okay? If I were to type this thing into the calculator, this thing into the calculator, I'm going to see where they cross, and they cross at only two locations between the values of, once again, the question asks, x is between 0 and 2 pi. So, if that's the case, 0 is less than or equal to x, which is less than 2 pi. I want all the values there, but there's only two of these that should check out. So I'm going to go ahead and start plugging them in. Sine of 0 plus the cosine of 0. Well, sine of 0 is actually going to be a value of... sine of 0 is actually going to be a value of 0. Cosine of 0 is actually going to be 1. Okay, on the unit circle. So this is 0 plus 1, which is 1. And that one checks out. Okay. How about the sine of pi plus the cosine of pi? Well, the sine of pi is actually 0. The cosine of pi is negative 1. And this is equal to a negative 1. That doesn't check out. Pi doesn't make any sense. Okay. Well, let's check the last one just to be safe. Sine of pi over 2 plus the cosine of pi over 2. And that provides us with, well, the sine of pi over 2 is just going to be a radical 2 over 2. Cosine of pi over 2 is, sorry, not radical 2 over 2. Sine of pi over 2 is going to be 1. Cosine of pi over 2 is 0. And this is therefore just 1. Again, the way that I evaluate all those is through the unit circle. So, I have only the values of x equals 0 and x equals pi over 2 check out. And this is why we should every single time check these values. Okay, and this is why we should every single time check those values. So that completes problem 2b. We'll look at the other two on the next video.